we are a shared space mission operator, and I will tell you a little bit more about that later on. Okay, so it's going to be a technical presentation with a fairly dive approach. You will not understand everything. It's fine. Go Google references, go dive a little bit on your own, okay? My idea is that I'm going to layer a cake. I'm going to do a very broad overview of what happens when you do satellites, when you're past, okay, I have a fixed design, I have a fat sat, know what, okay? And go across all aspects, let's say here, quite shortly, questions, and then a more deep dive on some key interesting aspects of the phase D of a space program. And I need to stop talking about phases without showing you what the phases are. So there are standardized project management phases across the space sector. It's fairly common to use them from 0 through F. Very early phases of ideation and preliminary design, 0A. B is a preliminary design, but it's already fairly advanced. Phase C is the critical design phase, which is really, it's the examples I put below. You do a PDR at the end of phase B, which is, okay, roughly how many screws do you need for something to hold? And then you do a CDR at the end of phase C, which is the critical design review, which is, okay, exactly how many screws, what type of steel are they, what heads, how do you attach them, how do you glue the heads, how very exactly specifically in the schedule you're going to do these screws. So this is the kind of critical design. And then you have the later phases, which is what I want to focus on here. The standard project management for space is shared between the Americans and Europeans, and also in most of Asian backgrounds. Indians have a similar concept. They have different phase names. Okay, so when you start from this fixed design, you know exactly how many screws, you know exactly the class of steel. You need to start making the stuff. So you need to manufacture, qualify, and test. And you should have chosen at this stage one key aspect, which is, do you make or do you buy? Everything that you will have on your satellite, you either make or buy. In both cases, you will have to test what you are bringing to space. This is either done at a system level once everything is assembled, but if you see an issue in a smaller brick, you probably should have tested before this smaller brick so that you decrease the risk overall, okay? Risk is a key element here. You can also say, I'm fine with the risk. I don't have time, I don't have money, I'll just test once in the end. So again, qualification, it's a concept that we'll come back to on later, is linked to confidence and your ability to trust your design in going to space and working there. And then the section D is the moment when you do the rest, the non-space segment aspects of your space system. So a space system has a space segment, it has a ground segment, it has a user segment. It's very important to remember there are three aspects, not focus on the space segment because it's the cooler, let's say, of the three. I put a screenshot on the right. Do you see my mouse hovering with this make a difference written on it? I added the make a difference because SatDogs, it's a crowdsourced initiative around satellite ground segments. It's a wonderful initiative, great people, awesome technical introduction to space systems, and I absolutely encourage you to set up SatDog stations across your different regions. There is a literal hole, like it's only people from the northern hemisphere, like mostly Europe. Make a difference here, and it's fairly accessible. You can really do it from the shed if you don't have a lot of resources. Okay, you can have fancy some stations. Some stations are fairly fancy, but you can also really do it from the shed. So in this phase D, you do the operations planning, you do detailed trajectory, and also filing for legal aspects. We can talk about that in the questions. Very likely your country has a space law. It's being more and more common. If it doesn't have one, you're in a gray area, and it becomes complicated. What happens once you have fixed your design, you have manufactured everything, you have a ground segment, you have a user segment, you go through the launch campaign, which is usually 2 to 3 weeks for a small satellite. You have something that is on the table that is already accepted by the launch because you have already done the acceptance testing. How do you have it accepted by the launcher? You read the manual. And literally, you have it on the internet. Every rocket that you will fly on, every dispenser you would be using, anyone who would bring you to space will provide you some user manual that explains to you what you need to do. And it's usually very detailed. Actually, the SpaceX hosted payload user guide is a very good example. Rideshare payload user guide. Just read it, like print it, read it, and you have done your training. Bravo. So this is an important aspect. Acceptance, shipment to launch site. Small satellites, you can bring them in as you carry on, literally on the flights. You take them in your suitcase and you go on the flight. No one asks questions. It's always funny when you go through customs with the satellites and no one's like, okay, fine. Who cares? It's just some electronics in the end. And then once you're at the launch site, either you or a subcontractor who works for the rocket company will be doing the final checks and battery charge. You need to remember that most of the space of the rocket flights will be canceled or like shifted around. And it's very important to be able to stay in sleep for several weeks, sometimes months, because there are delays, and sometimes delays happen after you're under the fairing, and once you're in the fairing, oh fuck. Okay. And so then, oh fuck, it's a PDF export. It was a very nice GIF of panel deployments. Okay, so imagine top right is panel deployment, and bloop, 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 it flops. Then maybe you can show some videos of that in your own training later on. Once you're deployed from the rocket, so the rocket goes to space, ejects the satellite, there is a phase of early operations. You deploy the panels, you calibrate your payload by taking pictures of things you know. You check that the telemetry is nice. You always have problems because thermal is complicated. For example, you will have issues with the thermal management. So it's part of the LEOP to sort of settle the thermal ranges in the satellite. So this is really this phase. And then if everything goes right, you go from no signal detected on your ground segment passes to, oh, there's something, and maybe you can start operating your satellite properly. Okay, so this is a very broad overview. Sorry.
Sorry to cut you off. Could you go to the previous slide, please?
Yes.
Yes, thank you. We are students, so we are now trying to learn to get into the space field. Could you explain the beep and the panels and the payload for those of us? Could you please? Thank you. Thank you very much.
Okay, so are you familiar with what a payload is in a satellite?
Please, we are not. Thank you.
Okay. So again, sorry, I'm settling a bit to the public here. Okay, so a satellite is basically split between two aspects. You have something useful that you gather data with. It's a telescope. It's an Earth observation camera. It's an antenna to broadcast signals, etc. This is the payload because it pays for the flight. This is the actual useful thing that you put in the satellite. Okay, so this payload is in opposition to the platform or bus, which is the batteries, solar panels, computers, reaction wheels, stuff that make the payload able to work. Because when you're in space, you need to communicate, you need to reheat yourself, you need to orient with regards to the sun, also the Earth, things like that. So payloads are the useful bit. Platforms are the heavy and costly bit that you need to have so that the payload can go to space. It's literally the backpack that gives you the range to go to space. So solar panels, lots of them, most of the satellites have deployable solar panels. So you'll have them folded. Think of your ears, okay? And then they release so that you have more surface area. without needing a bigger volume. So you can compact them in a smaller volume and then expand the solar panels. There are some limitations. It's a risky operation because if it fails, you don't have a satellite. So, oops. So this is the same with some kinds of antennas that deploy as well, that you use to communicate with the satellite. And so the beep I'm referring to is the fact that when satellites early in their life, when satellites are launched, they have an automated startup sequence, all of them, that will wake them after they're released from the rocket. So, okay, you put a rocket, your satellite, and you sort of have a disable cable that blocks it until it's ejected from the rocket in space. And once your satellite wakes up, it will usually start emitting a beacon to say, hi, I'm here, to your ground antenna so that they can find it. Because rockets are precise, but not super precise. So you need to have something that tells you, hi, I'm here, and shouts at you so you can find it in space more easily. And you can track and start communicating with it. So this is what I'm referring to with this kind of beep aspect. It's literally what you can see on the picture on the right. So if you have STEM background, you probably have recognized a waterfall of a spectrum. Left to right is frequencies, top to bottom is time. And the color is dark when it's not low amplitude and light blue or yellow when it's high amplitude. And you can see that there's noise here in the background. And you have a signal here, which is just beep, beep at a known frequency saying, hi, I'm here. Okay?
Okay, we're good. Thank you. Thank you, Baptiste. Very good.
Thanks. Don't hesitate. If you have more questions, I understand I went very, very fast on all of these aspects because, again, the goal is to not to tell you how to make a satellite and what's inside. And you probably have had these sessions, but more than what, okay? Do you have more questions then? I have put a couple reflection points if you want to think in the background. Maybe you can have a discussion on that as well.
Okay, that sounds good. We have one question in the chat, however.
Yes.
Jerry is asking, under the launch campaign, why does your system need to stay in sleep for several months? And when it comes to anomalies, how do you tune the software?
Yes. So the launch campaign is really this moment when you have a satellite which is qualified and ready to go to space. And then it's up to putting it inside of the rocket. Okay.
Yes.
You do it at the rockets, at the launcher's facilities. Why do you need to be able to stay a long time in sleep? Is that most of the satellites that you will do are containerized, so that you put them in a box and then you screw the box on the rocket, and once it's in space, that box ejects your small satellite. Okay, you don't bolt the satellite direct to the rocket. What this means is that you cannot plug a cable to charge the battery once you're in the box. You can't recharge the battery once you're in the box. Why the fact that you may wait for weeks or months is that sometimes rockets are delayed. Sometimes the weather is shit. Sometimes the main satellite has a problem and then the whole flight is held until the main satellite is fixed. Sometimes there are paperwork issues. Sometimes Russia invade Ukraine, and then this is exactly what happened to OneWeb. They had a full fairing of OneWeb satellites. Russia invaded Ukraine. The satellites never took off because it's a European company. The Russians weren't going to launch a European thing just after invading a European country. Okay, so and then all the small satellites around had to wait. So then they found other options, etc. But if, for example, that invasion had solved itself very quickly, they would have launched maybe 2 months afterwards. It's not a reason to change a rocket if you're 2 months delayed. Usually, to give you an order of magnitude, the contracts that you have with a launch vehicle say that you need to hold 90 days with no change, no information, nothing. They can just sit on the launch pad for 90 days in the sun.
Wow.
And 3 to 6 months, you need to explain to them how to take out your satellites from the dispenser and recharge the battery. And contracts have provisions that after 1 year of delay, you can start suing them to cancel. but not before that. And most of the rockets will not give you back your satellite. They'll be like, yeah, no, okay, no, it's too much logistics. I keep the satellite. So it's an important aspect. I remember there was a second part to the question, but I forgot it.
When it comes to anomalies, how do you tune the software?
It depends a lot. If you have, because you need to telecommand your satellite, you have an uplink, so ground to space radio link. Within the telecommands, you can have telecommands that change parameters in the software. So this is one way of tuning how the software works, because you can have somewhere in the software a line that compares a temperature with a set point, and then you can program in your software when you're on the ground telecommand to change that set point. Actually, it's good practice to have everything that is a set point tunable from the ground. You should have nothing that you cannot change from the ground in this kind of compared to a known reference or compared to voltage or compared to something. This parameter aspect should be fully tunable. It's a good practice from the industry. So expectedly, you will be able to tune the parameters. So that's one aspect, and it's 90% of the fixes of the tuning I'm referring to. Okay, 10% left is updates to the software, and again, this is becoming more and more common that you can update your software in flight. And nowadays, 2025, it's almost universally possible. I mean, you should have a in-flight update option for everything that has software inside, with safeties and securities, with encryption checks sometimes, so that you don't mistakenly erase everything. But it's so easy to have a mistake and then you can't flash it, and then you're done. That also enables something that a former mentor of me told me a long time ago. He was like, yeah, guys, very good, write good software, but remember, I only need the safe mode. If I have the safe mode and the satellite doesn't die, we can reprogram the rest in flight. And they were actually relying on it. They were like, this functionality, we will write it once it's in flight.
Okay.
So nowadays, it's very common to flash your software. Give you orders of magnitude here. A typical firmware for a small microcontroller is a few tens of kilobytes. You may have some kilobytes per second, 10 kilobytes per pass, for example. The target is that you should be able to to flash your software in a week, because it's the kind of cycle that you have of you upload small bits, then once it's complete, reflash.
Okay.
It doesn't work, etc. This is the order of magnitude.
Okay. Okay. Thank you. Yeah.
Nice. Maybe on the reflection points, if you want to take 2 or 3 minutes to, it's my homework aspect of when you take these slides again with your own team or organization, thinking of, okay, how can I sit and think about what I'm trying to do. Remember that dollar per kilogram doesn't mean anything. You need to have a proper quote from a broker. They can be surprisingly higher than you would expect. Anyways, all good?
Yeah, good.
Nice. Action 2. So again, I've talked about DEF, I mean the late CD phase in this broad overview, and I want to dive on a few more specific points of, I have a prototype on a test bench, and I need to turn that into a folded up and tested satellite ready to fly. Everything that I do between these, I need to have plans, because you usually have a short period of time when you do that. You will have designed the satellites from phase 0 to C over several years, and usually the phase D is less than a year in terms of calendar time. So I will go through 4 points. the idea of growing confidence, bring a discussion on qualification, but I think it's going to go over your heads. We'll try anyways. Please interrupt me if you're lost. The whole improvisation thing, and I want to tell you a little bit about what we do at Space Locker, because we sort of go around some of the problems I'm going to dive on. Again, please don't hesitate if you have questions, interrupt me or post them in the chats. I don't have the chat here, but you can. Some people can read. Anyways, so the same way you have for many technological projects, when you have a prototype, you need to grow confidence in that prototype before you put it in production. So as you grow this prototype into a more permanent flight model, flight ready, okay, really the real deal, let's go kind, you will be going through a verification phase, both for function and for the resistance to the environment. What you can see on the right is a full test bench for a ESA satellite. So it's 3 or 4 stages top. You can see some air conditioning on the bottom because it's very hot in the room. And this simulates and stimulates. So it's like a fake sensor attached to the end of the cable that pretends to be reading some things. The onboard computer for a big ESA mission. So this is one aspect of growing confidence, which is the functional verification of the verification of functional chains. They call it in Thales, and I think it's a relevant way of calling it, which is a different problem from the paperwork aspects of integration, validation, verification. Functional chains and requirements are sort of links because the functions solve the requirements. But first, you need to have things talking together before you start trying to tick boxes. Anyways, so there's a need for some kind of formalism, of some kind of paperwork that you need to tune and set up for the right amounts, depending on your project, depending on your team and your organization. For example, organizing boards where you come every month to see what's the progress, have checklists of requirements, which one is actually tested to be provably working in the system, which one is in progress, etc. What's the status list, have documentation packages for the equipment you ship, etc. So I started on the top left, top right, bottom left, and then bottom right, which is the environmental testing. This is not qualification. What you're seeing is a structural model of a first mission. A structural model gives you confidence in your digital modeling. You sort of tune your digital modeling, your finite elements analysis, your computer model of your payload that will give you a lot of answers. Usually you need to tune it with some physical experiments. So it's not the real thing. It's a copy, it's a mock-up with fake mass inside, but it still gives you more confidence on the modeling. So again, this phase of going from prototype to production has a very important aspect of growing confidence. Anyways, one aspect of growing confidence is qualifying your equipment for the space environment. I want to point out a nuance that you will see in people who write about space. Space is very cold, space is very hot. You have radiations, you have a lot of vibrations during the launch in the rocket, okay? This is the environment that you need to resist to. There are 2 reasons for which you will test or validate against these environments. One is the fact that the rocket, for example, requires it from you. It's like a contractual requirement that you have tested that you don't blow up when you vibrate. And so then you just tick the box for them. This is literally acceptance testing, because they will accept your thing if it passes these tests. Okay? Acceptance has another meaning in the sense of requirements, but this is what I want to do. And then qualification is much more related to your own confidence on the fact that you will work. So separate requirements, please don't blow up. Please work. The rocket doesn't care if you don't work. This is two different aspects, and you need to think of them as sort of two different customers that you think differently. Okay? So this is one key aspect. It's a nuance. Do you have questions? No?
I think we understand. Yeah, for now. For now, qualification
Great,
is for us, acceptance is for them. So we are good. Yes.
Yes. It's a bit different because sometimes you accept for yourself, but it's a bit different. Anyways,
Yes.
environmental constraints are defined by standards, by the launcher, by your own analysis. You use margins, and then within these margins, you identify some aspects that you are less confident and you need to grow more confidence through qualification, usually through environmental testing. I just want to stress out that environmental testing for qualification is not a tick all the boxes approach. ESA has that approach. I think it's wrong. I think it makes sense when you're an ESA project because you have hard requirements on everything anyways. They have complicated problems. So they test everything because they have complicated failure modes, okay? And requirements for very high reliability. For regular people, you need to sit down and go through the checks and think before you say, okay, I need to go thermal vacuum testing, for example. Do you need vacuum? It's a legit question. What does it change between your test setup and your flight setup, where you have vacuum because you're in space? What does it change to have vacuum on the ground for your test for this specific problem or application or thing you want to validate? And so every extreme, every check that you want to perform on the ground in this qualification environmental testing, you need to sit and look for the cheapest way and the more straightforward way to test it, okay? Because maybe your requirement is you need to work when it's minus 30 outside. This requirement doesn't say that you need to work in minus 30 plus vacuum. It doesn't really change anything when it's cold anyways. So put it in the freezer. You have climatic chambers. They go to minus 40. They cost 10% of the price of a TVAC. They're big freezers. Okay, use them. This is this kind of just need approach. I want to share the fact that it's important, but it's not really a recipe. You need to just sit down and think about that. Another thing I want to stress out, and I think it's a very important aspect in the context of student-led programs and this more university enthusiast environments. There is, I don't know if you know the Italian company called D-Orbit. On the entrance to their clean room, they have a small sign that says, "Hi, you're about to enter the clean room. This is a different world. We stop improvising from this door." And it phrase it in a more funny way, but it's a very serious sign, actually, that says, yeah, we don't improvise anything in the flight area. You go out, you think about it, you have a meeting, you write down a procedure modification if you need, and then you go back in. And clean rooms are useful not just because they're clean, because in many use cases that you guys have, you don't need to have the dust off. The whole no dust in the air, you don't really care actually. When you just do electronics and some radio, no problem. Clean rooms put you in a mindset and they avoid foreign object debris, like small bits of stuff that will get loose and maybe mess up with your system. So the actual purpose, one of the purposes that they have, is this mindset of, okay, I'm doing the serious stuff now, and so I need to focus on the procedure and be methodical. You can have this effect differently. You can tape an area on the ground. You can have a closed off section of the building saying, okay, past this door, we're in flight model area, even if it's not a formally clean room area. Okay, it's as much useful for the dust as it is for the mindset. This is the key thing I want to share. Anything AIT needs to be written down. Anything you do is written down, and this is a habit you should be taking. I've actually put it in the points for reflection. How can you promote this mindset in your teams is something that I think is very important, because you don't train people on the spot to have this mindset of taking notes on everything. Okay, and again, don't forget the tooling. What you can see on the bottom right here is a satellite, but you have tools around. You have plastic supports, you have metallic beams and stuff, because otherwise, how could you put it down on the test bench? Here as well, this red thing is some tooling. It's a mechanical ground support equipment. This table likely has been modified to attach to the satellites and make it more stable. It's an important aspect that will make your life simple. You need to include it in your development plans. So, parenthesis, I've talked about this focus, some of the hard aspects, okay, of manufacturing of these, putting in practice aspects of space systems. What do I do in Space Locker? I promise you there's some context and some reason for that. So what we do is we are a shared mission operator. Our focus is hosted payload. A hosted payload is a smaller payload compared to the main reason that the satellite goes to space. That you put as a piggyback on the satellite that goes to space for a different mission from the primary mission. Okay, usually you do a hosted payload with a third-party person. So you develop a Earth observation camera. You don't want to build a satellite. Actually, like, anyone will tell you the contrary. You actually don't want to build a satellite. It's the annoying part of it. I don't build satellites. I buy room on other people's satellites. I put my stuff on their satellite. It's not mine. I didn't design it. I didn't build it because it's shit work. And they do the hard work, and I do the cool work. The cool work is the sensor, it's the payload, it's the value. Satellites, especially in the 21st century, are commodity. You can want to have your own satellite for some reasons around nationality, around sovereignty, around many reasons, okay? You can want to have one. We shouldn't think of them as the default. They're not the only option. They're the default one. They're not the only option. Dedicated satellites, especially for small dedicated satellites, probably are well replaced. I would not say all, because, again, exceptions exist, but almost all of them can be better replaced with a well-tuned, well-placed hosted payload for half of the price. Okay? And it's not a miracle thing. You have to do some compromise when you have a hosted payload, but it's a different system where you squat some space, some leftover space on the third-party satellite. This is what we do. This is our specialty. We have super straightforward procedures and stuff. We can probably talk about that like in another context if you're interested. But I want to stress out again that this is not the only option. As students, as university people, you should seek opportunities to go to space and to reach orbit that don't require you to learn how to melt iron. You can piggyback, you can shortcut, it's fine. Do the interesting bits, do the science, help your communities with some useful data because you know what you need, okay? If you want to do a satellite because it's fun, yeah, go. But if you need to access space with a sensor, think about also needing to reinvent the wheel. I think it's an important message. We happen to sell these services, but I think it's a broader message than that. And I have, I think, about 10-15 minutes for many questions.
Okay, if you have any questions, please, if there's a word you didn't understand, let us know. If there's any information, if there's anything else, even if it's a comment, even if it's a comment that you want to just bring out there, let's do that. Yes, anybody? Or we should wait until the end of the session.
You had a question. So
Let's finish now for me. So
Oh, yeah, it's a question. All right.
I have a closing slides. Just want to share some, again, reflection points for your homework.
Okay.
Some bring up questions. How can you, in your current teams, in your current organizations that are in the beginning of things, okay, with your ideas, I'm interested in this domain. I want to explore more of it. How can you already put in place a culture that will help you have an easier time later on when you actually do satellites or space hardware? Because what I've described around AIT also applies to just space hardware. So this culture needs to be built over time. It doesn't emerge from zero. Okay, we've been doing this for 3 years here with people who have prior space experience, and we're still in my company, current company, building our own culture around reliability, predictability, reproducibility, and this kind of quality management, so that we can find a good balance between too much paperwork or too much unknown. Okay, and reiterate, and I think there's a final slide on that. Yeah. If you want to learn more about the technical deep dives around small satellites, KiboCube is awesome. You should all watch the whole playlist. This is the base training we use for all of our interns at Space Soccer. I think it's 10 or 15 hours, the whole online class with very deep dives on radio systems and precise things. Okay, very STEM. KiboCube Academy, great resource. I think here the training can also be a great introduction to the specifics of pocket cubes.
Nice.
So yeah, feel free to raise more questions now. If you had more ideas. Yeah, otherwise, it's been a pleasure.
Oh, thank you so much, Bapti. This was very interesting. It was very, very interesting. And we have one question in the chat by Jerry. He's asking, when using the hosted payloads, has there been any legal avenue that you had to maneuver or any legal trouble?
I will say that we haven't had legal issues that we wouldn't have had for dedicated satellites. One of them is export control. The export of data produced by a space sensor to a third party is sometimes controlled to export. But this would exist both in the case where you're a hosted payload or a dedicated satellite. So that's one aspect, and the declarations and dual use aspects of that can be a bit tricky, especially for countries on the African continent where the laws are still getting there. Okay, so that's one aspect where we've had trouble. Another aspect that sort of actually is an asset when you are the payload owner is that when you buy a low reliability, low price satellite platform, usually it comes with no warranty. And most of the new space industry has this no warranty whatsoever approach, which I think is a little bit abusive of emerging players. Okay. Some hosted payload players have the same approach. We choose to have some minimum guarantees. And so this is why the payments are split between before launch and then during operations, because there is this reliability aspect. It's not really a legal aspect, it's more a contractual aspect. But it's a little bit more subtle when it comes to hosted payload than when it's for dedicated satellites. But otherwise, not many differences.
Okay. Thank you. If there are no more questions, I
had
think
a
it's about
question.
to start our next. Pardon?
Yeah, I had a question.
Oh yes, Daniel, please.
Yeah, hi. So just to understand this, so does it mean that for the hosted payloads, you have to find maybe a company that is already flying like a 6U or 12U, and then if they have space, you put the hosted payload, or maybe the
Yeah, we
company
actually
makes the bus and
no.
you
So
just
what? Yeah, what happens is really this: a company is going to space anyways. They have leftover space. We can put something else inside. Right. So it's an important order of the thought process. Otherwise, they're selling us a satellite, and it's a different problem. Okay. So hosted payload again. The main mission needs to go anyways, even if I'm not there. Otherwise, it's not a hosted payload. It's a shared satellite. It's not the same business. We host on satellites that are like 250 kilograms that have hundreds of watts of power. So you mentioned 6 or 12U. The kind of hosts I have are like maybe UARCs or Exotrail, which are fairly established, old and reliable players with big satellites, and that they have leftover space on these big satellites. So they also sell it directly. It's not as convenient as the kind of things we do, but they also sell this leftover space directly. We have like OneWeb. You have a permanent internet connection on these satellites that exists nowhere else on dedicated platforms currently. So again, this is not a this is a low budget, low complexity option if you want it to be, but it doesn't have to be. And we've done very complex missions. We have a 25 centimeter telescope with 5 meter ground resolution coming up in the next few months. It's you can do any class as a hosted payload as long as the host is big enough. Okay. Okay.
Okay.
Thanks for
yeah,
your
makes
question.
sense. Yeah, thanks.
All right. So yes, thank you so much, Baptiste. We have learned so much. We have been greatly encouraged, and everything is like we are really understanding things more. So from what Baptiste is saying, he even said he wanted to build race boats instead of actually doing this satellite business. Yes. So it just tells us that no matter where life finds you, you can fit in if you are willing to learn and do the work. If you are willing to learn, do the work, if you really want to do something, you'll be able to do it. And luckily, we've created this avenue with, SheSat Ghana, with Xavier Space Solutions, with Space Local. That if any of you want to go into space engineering or space science, you just have to ask any of us, and we're able to guide you to the right path. So that's what these kind of collaboration, these kind of training programs are for, to just open your eyes, give you the introduction, so that when you are going deeper, the learning curve won't be so steep. All right, so that's really great. Thank you so much. Thank you so much, Baptiste. I've really
Thanks a lot for
learned
having me.
from your talk. Yeah, you went for your talk. All right.
Great,
So
guys.
as we are
Thanks a lot.
here,
Bye.
yes, bye bye. Have a good. Oh wait. Before you go, sorry, 1 second. Is he gone? Oh, thank
Okay.
goodness. We want to take a picture, if that's all right with you.
Okay.
Yes. Yes. So let's all turn on our screens. Let's all turn on our screens and our big smiles, our big lovely smiles. I'm sure we've all brushed, so it won't be a problem. Yes, let's put on our yes. Thank you very much. Okay, so I'll be taking 2 pictures, so don't worry if you missed the first one. So everybody, big smiles. Okay, great, awesome. That was good. That was very good. Another one. Sorry. Yes. Okay. Thank you guys. Thank you very much for joining this session. I'm sure we all had a good time. The time for our next session, the hands-on session. Yes. So yes, Baptiste. yes. You can if you want. You can hang around to see what's going on if you like. Yes,
I mean,
but
I actually need to go. Thanks a lot for having me.
okay.
Pleasure to go. Uh, don't hesitate if you have more questions. I will share the
Mm.
slides. We can also chat by email.
Oh,
Have a
great.
great day.
Awesome.
Bye bye.
You have a great day. Bye. 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 Yeah. So Daniel, the floor is yours.
Okay, let's begin cooking. So we so I think from the hands, I think only two people have created their accounts, right? The Onshape accounts.
A lot more people. It was like four.
So you can
Were they
raise your hands
supposed
again.
to use
I think
some
we can
specific?
ask again.
Yes. Okay, so
Yeah.
just raise your hand if you have created the account. Yes, so Michelle,
Okay.
Clifford, Caroline,
Oh,
Jerry. Jerry is always part of the people who are
five.
doing good things. There's Priscilla, there's Solace,
Six. Six. Okay.
Solace, and there's about there's
Ah,
Priscilla texting too. Yeah, so we have a good number. We have a good number. And Rosemont was created it.
wonderful.
Um, yeah. So once again, I would like to reiterate that if you do not have a laptop or cannot participate in this session, there's no need for you to worry. Everything will be recorded so that as and when you need to practice on your own, you would be able to do so. Yes, Daniel, please go on.
Thank you, Jemima. Yes. Yeah, so it will be recorded. Yeah, you can always practice with the recording. So so before we begin, remember Baptiste was talking about was saying that small satellites are not directly screwed onto the rocket, but they are placed inside like a box, like a shoebox, right? And that
Mhm.
box is screwed onto the rocket, and that so when the rocket goes into orbit, the box brings out your small satellite, and then the box it comes back with the rocket. So so today we are going to be building a simple pocket cube structure chassis like the primary structure of a pocket cube, and we are going to build it in such a way that it's going to fit within the box that it is intended for, the box that Baptiste was talking about. So usually before you start, you need to research. I can send this document. I'll make sure I send this document. It's from Alba Orbital, and is the company that launches pocket cubes to space. So they make that box. So usually, if you want to make a pocket cube, you have to go to their website, take their it's called an interface control document, more like a manual, like a user manual to using their box. So this is the manual here, and we are going to look at the dimensions and what it takes for us to build one to fit into their box. So you just have to scroll down. There's a lot of interesting stuff here. You can always read about pocket cubes and also requirements and specifications. For today, we are going to be building a 1P right here, a 1P pocket cube, the first one on the table. So that's the smallest size of the pocket cubes. And as I said from yesterday, it has a dimension of 50 by 50 by 50. The sliding back plate here will go into more details about what that is, but it's more of like the interface that sits, it's like more of the legs that sits into the box so that the satellite is able to be stable. So we'll look at that soon. But yeah, so if you are going to design this 50 by 50, and this is the dimension of the sliding plate, and also in the interface control document you have some drawings, right? So you need to just take your time and look at these drawings. They're really simple to analyze. They have drawings for a 1P right here, drawings for a 2P. So in case you want to build a 2P, you can look at this drawing. In case you want to build a 3P, this is the drawing for it. So today we are going to be building this one. Can I change? Yes. Like this. This is much better. So we're going to be looking at the 1P. So the 1P, yeah, we are basically just going to design a box that has a dimension of at least 50 millimeters in length and width and height. And this plus or minus zero point 0.1 is called a tolerance. It's just showing that in case you're manufacturing, right, you can deviate from the 50 by maybe 50.1, or if it's smaller scrap, 49.9. That's the range you can have that. If it's beyond that or less than that, it wouldn't be feasible to launch into space. So you have to take note of these kind of tolerance values. Mm, yeah, I think that should be it from the document. Let me see what else I can show here. Yeah, so this is the sliding plate I was talking about. It might be difficult to understand now, but just to give you a gist. So this is like a bottom plate of the pocket cube, and this rail, like this structure you see here, is what's in the box, right? So after you make your pocket cube, which is the green thing, you are supposed to slide it into the deposit, like a sliding thing, right? So this plate will
Mhm.
slide inside it, and it's fixed inside the box. So when it goes into space, there's a spring in the box that pushes the pocket cube out. So essentially, the pocket cube will slide through this space here outside into space. So that's in general what a sliding plate is about. Yeah, and then it's good to read all these requirements. If I'm making a satellite, you need to read okay, like what it needs to have and things like that for like a pocket cube. They're all here, and yeah, I think we can dive into so for today, by the end of the
Great.
session, we are
Daniel, sorry,
yeah.
just some small announcement. Sorry about that. So,
Mhm.
we are all aware that we'll be getting like certificates out of this. So let's be aware of that. So, just stay on after this program and after this session, and then we see our lovely pocket cubes. You will be giving your form to fill to get a certificate. So don't worry, you will have certificates. Daniel, please go on. Sorry for interrupting.
No, no, feel free to interrupt. Yeah, so by the end of the session, we should be able to build this simple pocket cube structure. So I already just designed this before the session, so we can just see how this is done. So essentially, when you have this, I think those in tech or like in in universities and stuff, there's I think you guys have like a 3D printer around. I'm not if you guys know what a 3D printer is, but it's show by hands if you know what a 3D printer is, or if you have seen one or have one in your school. Okay, I have a couple of people, three, four, five. Oh, nice. Okay, yeah, good. Thanks. So essentially, when you build this right, you can just easily export it as a step file, and then I mean you do the usual process. You can slice it in like a slicer, and then put it in your 3D printer to print, and then you can actually have this model physically. So I would hope that maybe if we finish with this, and those who can do it and stuff, you can watch the recording after and maybe do it, and probably I post it on LinkedIn and tag us, and so you can see your pocket cube structures. That would be nice. So yeah, by the end of the session, we are going to build this one. So this is the sliding plate I was talking about, the one on the bottom here, and then the top here is the actual pocket cube structure. So now, so to begin with, do you guys have your own shapes on? Those who are doing it. Um, yeah, I'm using a 3D mouse. I'm using a regular mouse. It's difficult to use with your mouse pad. So I think if you have a mouse, it will be good. So I think when you open Onshape for the first time, so I think when you open Onshape, you'd see this interface, an interface like this. So what you need to essentially do is you have to come to create. So you click the create button here, then you hit on documents. Then I mean you type whatever you want, maybe pocket cube, or you can type 1P pocket cube slash anything, or you can type it your name or whatever slash SheSat Ghana. Yeah, and then click on create. Are we on the same page, or so I'm not sure. Are people actually going to follow alongside with me, or you guys prefer to? Okay, I'm seeing some thumbs
Yeah, I
up. So
think
okay,
it will be
some people
easier
are going to
for them to follow.
follow.
So
Okay, okay, yeah. They've raised their hands. Cool. All right. So if we are all here now, um, we're going to, so first of all, let's create the sliding back plates, the plates that, so essentially we're going to create each separate part and then create an assembly folder and then just join everything together. So first of all, we are going to create this, the bottom plates you see here over here in the red lines. From the drawing, you can if you go to the drawing, you can see that it says that for instance, look, for the 1P, one of its length is 64 millimeters. And take note, these dimensions are usually in millimeters. I think it states somewhere in the documents. Yeah, 64 millimeters by 58. Sorry, yeah, this. So this is 64 by 58, and it has a thickness of I think 1.6. How can I see that? Yeah, you can see that from here to here is 50, and then from the bottom plate to the top is 51.6. So if you subtract 51.6 from 50, you would get 1.6. But another easier way to see this is I think if you scroll to the bottom over here, you can see from this 1P diagram here. Oh, I'm turning it again. You can see from the bottom plate here that they've written 1.6. So in case you are not sure, it also shows right there. So now we'll click on one of the faces. Usually I just click the front face. So you can click on the front face and then click on sketch. After that, it opens the sketch panel for you right here. In order for you to see it like directly perpendicular to you, you have also the mouse pad, the mouse cube or tracking cube here. You can just click on front face and it would face you directly. So you can maneuver this however you want, so right face, back face, or whatever. But we will be taking care of this since we are using a front face. Yeah, show front face. So now let's start drawing. We have line tool, corner, rectangle, center points, things like that. So since we want to draw a box, we can use the line tool as well. So we can literally just start anywhere and then draw any line. Like one thing you can take notice that when you're drawing lines, if you want a straight line, you see there's when it's straight, a line comes, it shows you that the straight line, the black small line at the bottom, it just tells you that it's perpendicular, so it's straight. And you can click to stop the line and then draw another line. And I click. Now, one thing, so over here, for instance, look, I want to make an equal box. Like I want the length of this to be the same as this. So one trick you can do is that you can drag the line to this point and slowly drag it away, and you'll see that a dotted orange line is showing. It just like gives you the benchmark to how long your line needs to be. Click and then click here. Yeah. So now we have a do we have this box? Like, do we have just like a box? It could be any length for now. You can just need to draw 4 lines. Great. Yeah. I hope. Let me know when you guys are here by giving like a thumbs up here.
Priscilla Texan has a thumbs up.
Very okay. Cool.
And
Nice.
who?
I mean, a few is fine. So yeah. So we can continue.
Yes,
Thanks,
Hadassah. Yes.
Hadassah.
Yeah.
Nice. Okay. So now that we have a generic box here, now we are going to dimension it according to what the Pocket Cube standard was saying. So the Pocket Cube was saying that we need to have it as 64 and 58. So I'm going. So if you look on the sketch tab, you have this dimension D is right at the corner here. Click on it, and then click on any of the lines. It could be anywhere actually. So I'm clicking on my first one and I'm naming this, and I'll dimension this as 58. And just make sure your data you are in millimeters as well. I'll show you how to do that in case yours is not in millimeters. I think when you come here, hi Michelle, do you have a question?
Yeah, I think someone raised the hand. That was okay. The hand was down. Okay, I think it was a mistake. Carry on. Don't worry.
Okay. Let me see. Yeah, if you click on the the measuring tape over here, you can just make sure that your dimensions or your length unit is millimeter, so that you have the same. Like make sure that it's not in inches or whatever, but it's in millimeter, so you can follow up with the.
Jerry is he said, can you okay, two people have problems. So first of all, Jerry says, could you go back? Could you explain go back where, please? And
Is it when
Solace
you click on the front face, it doesn't
Jerry, is that what,
show? Okay, I'm coming.
is that what Jerry meant?
So I'm
Okay,
I'm
when you
I'm just coming
clicked
to
on the
start.
line. He said when you clicked on the line. Okay, so
Oh, the
Solace
line.
2 is
Okay,
yes, when you click on the line. Yes, that's where he
sure.
had the issue. Then Solace 2 is asking when I click on the front face, a sketch doesn't appear.
Yeah. So over here, so sketch is here. This is
There it is.
the button. This is the
Uh-huh.
button. So you should have this button. So essentially, I clicked on front and I just clicked on sketch. So sketch is always there, regardless of if you click on front page. You just have to click the button, and then yeah, now you have these tabs open.
Okay. All right. So I think for now, yeah. So when
Okay,
so Jerry say go back to when you clicked on the line. So is that where you've
yeah,
gone?
the line. Yeah, no,
Yeah.
I let me draw it again.
Okay.
So I'm drawing my line. I click, 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 click. So on the line, you mean like four dimension, or is that what you're saying, Jerry? Are you talking about two dimension? Dimension, yeah. So when you click on the dimension button here, first you need to click on dimension first, the button on top here. So when you click on it, then you have this, then your cursor will change to like a plus sign. Then you click on the line you want to dimension, click on it, and you drag it up. So you can drag around and stuff. And then you can label this as 58. Yeah.
Okay.
So that's how you dimension. So you first need to click on dimension first. Um now since it okay, cool. So now since it said that one dimension is 58 and the second was 64, we are going to dimension this as 64. 64. So now we have the right dimension for the sliding plate, right? Cool.
Mhm.
Now this is just a 2D sketch. Like we just have the dimension, right? But it's a full box, right? It's a box. So I mean, like it's a rectangle. So you have to also know the thickness of it, and that's what I showed you, and it was 1.6. So to do that, we have an extrude button here. This is the extrude button. So if you want to make it from a 2D to a 3D, you click on the extrude button, and then you can click on depth, like how big do you want the box to be. So when you click on extrude, you type 1.6 and hit enter. And when you rotate the mouse pad, you can see that it has extruded by 1.6. So you can even use the arrow here to increase or decrease the thickness. You see, if you reduce it increases, it comes down. So yeah, I'm typing 1.6 here and then hit OK. So there you go, you have your sliding plates. Let me know by thumbs up. Like you can take your time, but let me know by thumbs up like when you're able to uh do this.
Yes, some
Jake.
thumbs up.
Yeah, Jake,
Some
how
thumbs.
far?
Okay, Jake's
Okay.
thumbs. Okay, James just has thumbs just up. Okay, everybody seems to be all right.
Is it only Jake who has his thumbs up or someone other people?
Yes, I think it's just Jake from looking at
Yeah.
the chat.
Let me know
So
if I miss, like if you are lost, I can just go back and
yeah, show you how to do it.
yeah.
Once again, it's okay to just follow. It's okay to just
Yeah.
follow. If you have a laptop, it's okay to just follow. You can do this at another time. It's okay to just
Yeah.
follow. You get your certificate regardless. You only have to fill the form after this session, so don't worry about that. Priscilla says she's lost.
Yeah. Okay, so let me so where are you now, Priscilla? Are you on the skate? Like at least do you have this? Are you on this portion? Here. Are you here? Like do you have this lines with these dimensions? No,
She said
okay.
she's
So
not there. Sh- No.
the line two. The line two is here. This is it.
Okay. So Priscilla, where are you then? If you are not here, where are you? So while we wait for Priscilla to type, Michelle has raised her hand. After
Let me
Priscilla
show you.
shows us where she is, you can unmute yourself. Yeah. Oh, so Michelle's hand is raised because she has reached there, right? I think so. I think so.
No, that's not okay.
Oh,
What?
okay. What is the? Oh, you can. I can't hear your voice is low. Can you increase your?
Okay.
Okay, front view.
Okay. Can you hear me?
Yes, you can hear you now.
Okay, so the issue is I think it's either I'm using a different interface because I don't have the same thing. So I'm struggling to find I've been able to find the line, I've drawn my box and everything, but then I can't find the dimension to
Don't see it here. This.
yes, but it's I don't okay, let me turn my camera.
Mhm.
Okay.
Maybe how do I turn it?
Oh, you want to share your screen?
No, I just want to show you something.
Oh, okay.
I'm using a different interface. I don't know. So wherever he says we should click, I just need to like figure it out myself. So I can't find any dimension. Maybe I downloaded the wrong app. Could be.
Daniel, can you see?
Dimension. Yeah, I can
Is she
see. Yeah.
using the web version or
Yeah,
something?
it's only web. It's only the web version. Like the
Okay.
Onshape doesn't have an application. Make sure your camera is off.
Oh, yeah, Michelle's camera is off now.
boy.
Okay.
Please continue.
Okay,
I'll
let
follow
me.
up.
Okay, let me just. So let me do it again. I'm coming. I'll take it slower this time. So I don't know which version, but the one I'm using here, because I sent a link to the version. But anyway, I think Onshape should be the same anyway. But I think there is a search tool here, a search button here. So if you type maybe dimension, it should show. But it's just like you have to be in the sketch mode for dimension to show up. So first of all, I'm starting again. So here's the beginning phase, right? So I think let me look at the chart again. I think Priscilla was saying something. I'm still on the front view, but okay, I'll go there now. And then dimension to millimeters. And Stephen, yeah, yes, the thickness is 1.6. So dimension to millimeters. If you look at the bottom here, come, let me just unpin this. If you look at the bottom here, they have show measure details. It's the first thing here. It looks like a folded measuring tape. So if you click on it, length units. Mine is a millimeter. You can click on the drop down arrow and change it to millimeter. If it's not in millimeter, so you can change it here. Yes, so it's right here at the corner. So now I'm starting all over again. So when you open Onshape, you have this view like this. Now we are sketching on the front face. So what I do is I click on the face I want to sketch, so front face, and then now I click on the sketch button. This sketch button opens the other tools like dimensions and line and things like that. So when you click on sketch, now you see I have my line tool here. I have box, circle, 3-point arc. I have dimension also here as well. But I think if you search for it, you can find dimension. Yes, on the search bar, dimension will show here. Also, there's a shortcut. You can click on D to just activate dimension, and also L. In case you can't find line, you can click on L on your keyboard, and then the line tool your mouse will automatically turn it into a line tool. Now that I'm in the sketch mode and I'm drawing on the
So
front face,
sorry, there are some
yeah,
questions. How do you
yeah,
make the dimensions to become millimeters?
yeah. I already answered that. Yeah, like
Okay,
I
and
read
the
the question and
thickness
answered it.
1.6.
Yes,
Okay,
yeah, I
okay, good.
already answered this
Michelle's
question.
hand is up. So
I'm sure. Yeah. Do you have a question or it was by mistake?
I think
Michelle.
maybe it was still on. Okay, okay, let's
Okay.
carry on.
Okay. So now that I click the front face and then I clicked on sketch and I'm here, I'm going to click on front here just to make it face me, directly, right? And now I'm going to either type L. So let me click on L. It's when I click on L, automatically it has changed to line tool. So in case you can find it, there's a shortcut. I just click on L. And then I can just draw anywhere. And draw a box, make it straight, and then draw it here. So now I have a box. So are we here? Is everyone here? Like, do we just have this? Priscilla, are you here? Okay. And what about Priscilla? Yeah. Are you also? Yeah, you raised your hand here. Okay. Do you have a question?
Um,
I'm finding it difficult to even get the tabs like this. I'm not getting the line and all, so I'm following, but I can't practice.
Okay. Okay. But if you click on L, I think the line should come. The L button. By the way, so okay, I sent up my play before already. Yeah, that's fine.
yeah.
So yeah, I can just I'll just continue and make sure to mention all the shortcuts and ways you can do this, and later you can look at the recording and try it
Okay.
yeah. So
Okay.
yeah, okay. So now that I have this line here, I can click on D. Is when I click on D, automatically I'm in dimensions. So for I can just be using the shortcuts L for line and D for dimensions. So I click on any of the lines here. I can click on the one here. Click again. So when you click on it, you need to click again to change the dimension. Maybe like 58, and then I'll click on this one and make it 68. Sorry, I think 64. I'll click again. Is it 60? Yeah, 64 and 58. Yeah, 64, 58. Now, still in the sketch sketch phase, we come to extrude. So over here, you can find extrude here. And you see, when I hover on it, it gives me the shortcut. If you do Shift plus E, you can get the extrude button. So when I click on extrude, I'll click on how much it's supposed to extrude, which is 1.8. Sorry, the thickness is 1.6. So 1.6 millimeters. And click enter, and you click on the green check mark right here, and you can see your extrusion. It's right here. So it's as extruded by 1.6, and then the length is 58 by 68. So now we have our sliding plate. If you look at the tabs here, it's called, we have assembly one, and then part studio. Part studio is your part file. You can right click on it and rename and type sliding plate. Hit enter and you have that. Now we are going to create the is that just a stack on inches. Yeah, I was thinking, so if you have this tool here, this button here, show measure details at the bottom here at this side, you can, where my mouse is, when you click on it, you can change it. Length is here, length units, and then you can click on millimeter, or if it's in foot, you can change from foot to millimeter, and then it will change all the dimensions. So now we are going to create a different parts. So to essentially how this structure, like how CAD design works in Onshape, or even in different softwares like SolidWorks and Fusion or whatever. You need to create the parts separately, like this, like a part here separate, and then so you have like multiple parts, and then you have to import all of them into this file called here assembly, and you just have to now bring everything together like a Lego in that sense. So now we have created our first parts. So let's create our second part. So you can click on the plus button here, which it's called insert new tab, and then you can add a new assembly or create another part. But since we are creating a new part, we'll click on create parts studio. Create part studio. So I guess now everyone is just watching, right? For now, or there are some people that have done the sliding plates. It's all right if you've not done it. I mean, it's recorded. So Steven done. Okay.
Yeah, I think yes, Steven has done it, yes. And Jerry's
That's fine,
done it
yeah.
still inches.
Yeah.
Yes.
I think you have my those of my I'll put my LinkedIn here or my
Yeah.
something. You can always text me like if you have any questions or something. Yeah,
Okay,
yeah, Jerry,
Caroline
yeah.
too has done
That's
it.
fine, yeah. Caroline thing. Okay, cool. So I'll place my LinkedIn here, and then you can always message me when you're watching the videos and you have any questions. You can just message me on LinkedIn or
That's
send me like
awesome.
an email. Yeah. Okay, so after you create the sliding plates, reminder, so you click on insert new tab, then create part studio. So you can create a new part, and you have this. Now we are going to create the actual box, this box right here, this square here. So now we have created the sliding plates here. We are going to create this part, which is a box, and it weighs 50. As it weighs, it has a size of 50 by 50, and also the height is also 50 millimeters. So let's click on front face again. So the same thing as usual, click on front face or any face, right face, bottom face, it doesn't matter. It can be anywhere. So I can even click on what top face. I can click on top face, it doesn't matter. I can click on top face, hit sketch. And then to make it like perpendicular to you, you can rotate the mouse. By rotating this, you just have to click on the scroll button on the mouse, and you can click. I mean, like you can rotate it, and then if you want to be able to have a pan view, like to move it sideways without rotating, the same way you click on the scroll button, but at the same time you click on control. So control plus the scroll button, like as in pressing on the scroll, like on the control button, you can also move it sideways. Yeah. So let's go top face, right? I'm sketching on top. Yeah, top face. So I'll click on top like this. So I have the view perpendicular to me. So the same thing, we are drawing a box, right? But this time let's use the corner rectangle. And instead of using a line because you want like a box, right? So I'll show you how easy the corner box works. And a corner rectangle, you can click on G also on your keyboard. Jake, do you have anything?
Yeah. I'm sorry for interrupting. I think um I think that the Onshape, right, has sort of a mobile version, and so Michelle is using I think she's using a Chromebook system, right? So I suspect that's why it's a little bit different. 'Cause it
Different.
shows up application, so the interface is a little bit different. I don't know if it will be the same
Yeah, it's better
for.
to use a PC. Like
Yeah, she's using
like
Chromebook is a PC, but it uses the Android system,
yeah,
right?
Chromebook, yeah,
Um,
Android, yeah, I remember.
yeah, so I don't know if what's the
Let me
name?
see.
MacBooks also have that nuance, but I'll just suggest for everyone to open it in your Google Chrome browser, and then you should be able to have the same interface. Yeah, thank you.
Okay, let me check here. Yeah, because on my if I open Onshape on my phone here, I can see that like the interface is different. I feel like you can't even I don't even know how to card on like a tablet or something. It's so different. So yeah, okay, I see. Yeah, I think it's what Michelle was showing me. Yeah, it has a box and then it shows the stuff like this, right? It doesn't show it on the top bar like that. Yeah,
Yeah,
I think I see that. Yeah, okay.
just a suggestion:
Yeah,
everyone should use the Google Chrome browser, or I think that
yeah,
should fix it. Yeah, instead of using the
yes.
app itself,
The
that'd be
app,
a
yeah.
little more complicated. Yeah.
Okay, thanks. Yes, yes. It's just when you're watching the video after, it's better to open it on like the browser itself, like on Google, like the Google browser, and then so basically you can just like come here on Google, right? Just click you can type Google, sorry, you can type Onshape on Google, Onshape login, since you've created your account, and then so better use Onshape from like Microsoft's Bing or Microsoft Edge or Google Chrome, but the actual browser. So you can click on Onshape here, and then you should have the homepage for Onshape. So okay, because I've already signed into Onshape, it's automatically open. But yeah, that's how you can do it before you start the practice. So web app, but it's different than maybe some of the tools and menus are. Yeah, Steven, if it's Chromebook, it should be the same. Okay, web app. Yeah, but I think because she's using, I think like the Android OS, right? Because when I open the app on my tablet, right, it's way different from view end product. Yeah, so it's way different from like the actual. Yeah. Okay, so I'm going to use corner rectangle now. So just a recap, we are here now. We are coming to card the box, the actual structure here, which houses the avionics and batteries or whatever. And it's 50 by 50 by 50. So to make it simple, I'm just going to draw a box. Using the corner rectangle, it automatically draws all the four sides for you without having to use the line tool to draw each of the four sides. And now that we have that, again, dimension. Going to dimension this at 50 millimeters, and then this side at 50. So we have all our sides as 50 millimeters. You don't need to dimension the other sides because it has already been dimensioned. Uh, let's confirm. Yeah, 50. All right. So now that we have this, remember the height is also 50. So the same as before. You'd come to the extrude button here, and then you type 50. So instead of 1.6, because that was for the sliding plate, now you type 50 because now I'm making the pocket cube box, and that's 50 millimeters in height. And click OK. Now when you rotate it, you can see the box now. So this is the 50 millimeter by 50 millimeter by 50 millimeters. So you have that. Let's go back to the top face. Let's show top face. Yeah. Okay. So now that you have this box, now that you have this box, those who are able to follow, are you having any problems with the box? It's fine. So now that you can always type a message in the chat if anything. Done it. Cool. Okay. Now that you have this box, and Caroline, I don't know if you've done it. If you've done it, you can just say done. Um, now that we have this box, we are going to very cool. Okay. We are going to create. Can someone kindly resend the WhatsApp channel link from yesterday? Okay.
Okay,
No, can you
I'll
send
do
that?
that.
Yeah.
Yeah, I
Thanks. All
can
right.
do that now.
Okay. So let me quickly, because I have like 30 minutes. I have to go somewhere. Let me wrap up.
Okay.
So now that we have the top face, right? Let me go back to what I did before, so we have an idea of what we are doing. SheSat, yeah.
So Caroline has said that she has done it. So very good.
Nice, thanks. Okay. So this is the final one, right? And looking at this, right? The box, right? Now we have created the box. So now we need to make a hole inside, like we need to make it hollow so we can put stuff inside the box. So that's what we are coming to do now. So that's how you begin stuff. You need to make a bulk structure, and then from there you modify it and make it what you want. So now we started with a plain box. We will come to the top face here. Now let's cut a hole inside so we can actually put stuff inside this box. So I'm going to click on, you can click on any face you want, right? But I'm coming to the mouse my party. I'm clicking on top face, and then I'll click on the top face of this. I'll click on this and click on sketch. When you do that, I'll come again to the corner rectangle here. You can also click on G in case you don't see it. You can click on G to have that. And I'm just going to draw a box inside this. Yeah, so from this box, I'm going to cut through it so I'm going to cut all this space over here so we can have a hole inside. So usually for satellite structures small like this, 2 millimeters has been proven to be strong enough for in terms of structural integrity. So we are going to make it dimension each of these wall. I mean like the thickness of this to 2 millimeters. So we come to dimension, and then what you do is you click on this line and also the box line here. So that gives you the dimension of that space, right? And we are going to make it 2 millimeters. And you just have to do the same thing for each side. So now this side to the top face, make it 2. Click here. Sorry. Do it again. I did Control Z to go back because I made a mistake. So click here. Oops. Yeah. 2 millimeters. 2. 2. So now we have this, right? We have a box line inside the box tool, like this, right? So we have that, and now we come to the extrude button here. So now look, if you want to add something, right? You see there are tabs here. So in your free time, you can watch like YouTube videos. There's like a whole tutorial on YouTube. You can go YouTube and type Onshape tutorials, and there's like everything you need to know, right? So when you're watching these kind of tutorials, what you need to take note of is that you don't really need to understand what they are cutting. You just need to watch the video and follow what they're doing so you can know the tools that are available to you. Okay, like this is okay on Onshape. I can create a line. I can create like a ball, a circle. This is how I do it. So based on those features, basically if you want to design literally anything you want, you know that okay, this is how they did it. So you can know that, so you can now try some of the features around. Or at times you want to do something but I don't know how to do it. You can go on YouTube and type how can I create a ball in Onshape? How can I create like a chair? Things like that, or maybe like a corner bracket. They have like videos like that, and based on that you can learn. Um, so in the extrude tab here, if the add button means that you can add whatever you have there, right? You see, it's red because it doesn't add because like your line is over here. So if you're adding, you can only add what is above the line. But since we want to cut inside to make it hollow, right? We are going to switch to the remove tab. The remove tab right here. Now you see when I made it remove, it's now red because there is nothing in the sky, like there is nothing here to remove. But if I bring it below the line, you can see that it's cutting into the box with the dimension I made. So it's cutting, right? It's cutting. So that's how we can make a hole inside the box. Since the height is 50 millimeters, I'm going to leave a base thickness of um let me see how much I made it of 5 millimeters. So I'm going to do 50 minus 5, which is 45. So I'll make it 45 millimeters long in the cut. And as you click the green check marks and you have your box hollow. So you have this hollow box here and stuff. So that's it. Like essentially when you 3D print this, you can just fix your PCBs or whatever you have inside this. But of course, if you want to do like things like that, you have to go a little bit more advanced because you need to make like mounting holes inside that and things like that. But for today, since it's the first time, you're just making the primary structure like a general chassis, right? Like just to understand the concept of how these things are being done in CAD and using the actual like companies required dimensions and following those dimensions in your CAD design modeling. So now that we have the box, one feature that I added to like the box was I added like a text, maybe like I want to type my name or the name of my company. So since we are in the program, we'll try and type SheSat here. So again, I'll click on the face sketch on any of the face sketch and then make it perpendicular. And then you can see there's a button here called text. It has an A with a double shorted line here. So when you click on it, and then the arrow will turn to like a plus again, and you can just draw any size line here, and then the dialog box will come here, and you can type SheSat Ghana. Yeah, SheSat Ghana. So when you click on it, then you say okay. Now look, it's so big, right? So it has come here. So it has basically done a sketch of lines, but it has typed whatever you typed, right? SheSat Ghana. So let's try and make it small. We need to dimension this. So let's come here, click on this line and make it. Now it's 260 millimeters, but our pocket cube is only 50 millimeters. So let's make it like 30. If you come in, you'll see it here. Oops, sorry. Let me go back. I'm just going back to where we were. Okay, I think I went back too much. Let me redo it again. I'm going back to where we did the sketch, the SheSat sketch. But I typed Control Z too much, so it sent me backwards too much. All right. So I clicked on any of the faces, and then I went to sketch, and I clicked on text. Recording will stop in 2 minutes. You can re-invite to continue recording. Joel, do you know how to fix this?
I'm here, I'm watching. Ah,
Well,
has
it was
anybody
saying 2
has
minutes.
anybody else
Well,
been able to?
I think
hello?
I think because the meeting time was set to 2.
Okay. Okay, with the fireflies, I'm not using fireflies, so that's not me.
Okay. Well, yeah,
Yeah.
but it's just saying that the recording will end in 2 minutes. I want to make sure like we are
Oh, it's
recording
not us.
again.
It's not us. We are good. We are good.
Oh,
It's
it's
not
not
us.
us. Okay, okay,
No, it's not us.
okay,
It's not us.
okay. All right. Anyway, all right. So I went to the text sketch here and I drew a dialog box. The sketch. So I want the sketch to start from here. So I start from here. I just draw this and I typed SheSat Ghana. And I clicked on the button here. And then now to make it smaller, I just click on the top line here and I made it like 30. So it's 30 millimeters now. And then you can I think you can drag it up. Yes, you can click on the corner of it and drag it up. Yeah. Let's make it slightly bigger, maybe like 40. Yeah. And then bring it to like the center. The center here is fine. Yeah. And then since it's a sketch, right, you can also extrude it or remove as like add or remove. So you can come to extrude here. So now you see it's an add. So it has added material to the text. So you can also 3D print something like this if you want it like cool like this, like and like it really like extruded the text on your thing. But of course, like this is going to space and we cannot go beyond the 50. Well, yeah, cannot go beyond the 50. But what I would like to do is I would like to remove. So I would like to make it like a hole with SheSat Ghana. I want it to be on both sides, right? So I can take the arrow here and pull it along. And you see that it would also reflect on the other side as well.
Mhm.
And then just click on OK. And now you have SheSat Ghana on two sides.
Yay.
On two sides, yeah. And of course, and apart from text, you can do any other cool stuff you want, like on any of the sites. So for instance, I can come to this face as well, click on sketch, um, click on sketch, and then I can even like draw two circles. I can click on the circle tool or by clicking on C on the keyboard. Click on circle tool, you can play around, you can add another circle here. I can even draw two lines. It can be literally anything you want to do. I can draw two lines from this circle to this circle, another line, another line from this circle to this circle. And another feature that this has is called the trim tool. So you click on trim and it can delete lines that have intersections. Like there are 2 points here. So it can delete a line like that. You can trim this or trim that line or whatever you want, right? You can also trim this as well. Yeah, and then based on that, you can again remove. You can remove a sketch, just like that. But I'm not going. So there are a lot of tools available to you. You can take your time and then play around with all these tools in your free time. That's if you're interested in like card design and stuff like that. Let me delete that sketch for now. So now we have the SheSat Ghana. Now we are going to make something to cover it, right? Something to cover the sketch. So let me see what I did in the actual model. Okay, yeah. Right, yeah. So the ideas, and now we have our box, with with some space inside to mount our electronics and stuff. Now we need a way to cover it, right? Because we need the thing to be secured, right? It needs to be covered with something. So now we are going to create another part. So essentially we are done with this. We have designed our small satellite to fit the dimensions of a pocket cube to fit into the outer orbitals box that will go into space and then spring out. So generally this is it. We have this with the sliding plates. So we have done what is required, but this is more like just like common sense, right? Like based on what we have designed, there's like an empty space here, right? The manual is not going to tell you to put a cover or something. Like you just need to put a cover because it needs to secure your components. So we are going to add another tab. So create part studio. Space here. The manual is not going to tell you. So right now, let's click on front face again, sketch. Now looking at this, right, we are going to create yeah, let's rename this to primary. Let's name this to cube structure. Or component mount. Yeah, because the components will fit in this components mount box. So we want the cover to fit in these two. I mean, like on the top face here. So what we can do is based on what we dimensioned it as, right? We dimensioned this as from here to here is so essentially it is 46 millimeters by 46 millimeters, right? All sides are 46. So it means that we need to size our cover in such a way that it is less than 46 millimeters so that it will fit. Because if you size your cover exactly 46, it would sit on top of it, but it wouldn't enter, right? So you need to make it slightly small so you can fit inside. So usually you can set like a tolerance level, right? So you don't want it to be too small and too big. So since it's 46, can I type on the screen? Can I write on the screen? Anyway, yeah. Let's see. Oh, you can't see it. Okay, that's fine. I thought you could see my. Anyway, yeah. So, let's draw another box for the cover. Now, since the cover here, right? The thing that you want to put on top of this for it to sit on top to cover the components, right? Is the dimension of this and this is 46, right? I'm going to use like a tolerance of plus or minus 0.2. That's usually the standard, like plus or minus 0.2. So what it means is that I'm going to size it to 45.6 with the taking note I'm using a tolerance of 0.2. So it means that if I make this, let me dimension it. Is it on? Okay, let me draw it again. Sketch. Yes, I was saying that I was going to make this 45.6 because the actual length of that is 46, but we are trying to make something that will fit within 46, right? So I'm making each side 45.6. 45.6, which is not too big or won't be too small as well. And I was saying 0.2 tolerance is that so with this one, if you send it to the machine like the machine shop or like or the 3D printer, in case something happens and it makes it longer, right? We are just ensuring that okay, at least in case something happens, and maybe it shouldn't be longer, or as in like it shouldn't get closer to 46, right? We want to give some spacing with it in case there's some errors when the 3D printer is printing, or when the machine shop, like where you send the metal to them and then actually like cut to shape for you. So keeping in mind of 0.2 tolerance, it means that it can either be 46.8, sorry, 45.8 or 45.4, right? So even if they make a mistake and they make it longer, right? The highest it might go can be like 45.8, and then which is still below the 46, benchmark. But of course, if they go beyond 0.2, right, then you are screwed. So essentially, in also on Onshape, you can make drawings, right? So if you go on YouTube, you can type the Onshape drawing, and it will show you how to make a drawing of your card. And you can add the tolerance in there, that okay, please, when you're making this part, the gap I'm allowing you for error is 0.2. So even though you are seeing 45.6 here, you can make a mistake, but only to an extent of like 45.8, not beyond 45.8. Or let's say, if in case you make it smaller, maximum smallest you can do is 45.4. Yeah. Steven, you said 45.2 or 44.8. Yeah. No, well, 45.6 minus 0.2 is 45.4. That's why I said 45.4. So it means it's either 45.4 millimeters or 44.8 millimeters. Yeah. Sorry, I said, what am I typing? It's 45.4 millimeters or 45.8. It's not 44.8. It's 45. It's just 0.2, right? It's not like 1. It's not like 1.2. It's 0.2. Yeah. Okay. So with this cover, it depends on my preference. Now I want to make it 2 millimeters thick. So I'm going to add and then make it 2 millimeters, like the sliding plate. So now I have this. So now we have the cover, we have the box, and we have the sliding plate. So in the assembly folder here, in case in your tabs you don't see assembly, well, usually like it comes by default when you open a card space, like a document card. But in case you don't see it, you can click on the plus button and you say create part studio. Sorry, create assembly, and that will work. It would come. So in the assembly tab, the error margin. So the error margin, I was saying that since the cover we are making, right, is the size of this is 46 millimeters. We want to size it to fit within 46 millimeters, and then it shouldn't be too big or too small. So I have chosen that, okay, I will make my dimension 45.6, right? And then when I send it to the machine shop for them to cut into metal or something, right, I'm going to add the error margin to the dimension that it can be plus or minus 0.2. So right, 45.6 plus or minus 0.2, just to tell them that if they are trying to, in case they are trying to cut I didn't know it was 46. Yeah, so it's 46. Yeah, from what I'm using here, it's 46. Yeah, this one. When I come to dimension, you see, it's 46. So each of these lines here is 46. So yeah, so 45.6 plus or minus point two will be 45.8 or 45.4. Yeah. Okay. Um. So when you open the assembly, because I need to listen. When you open the assembly, you can now import all the parts you have made into the assembly folder, right? And then you can just join it together to make a full satellite. So insert, and you see all the parts you made here. Sliding plates. Let me name this cover. Rename a cover. So in the assembly file, you have cover, sliding plates, and then the component box. So I'm going to add a component box first. Click on it, click the cover, put it on top, click, and then sliding plates, and click. And then you can close this. Oh, sorry, I was supposed to click on the green check. So you click, cover, click, sliding plates, click, and then click on the box. Yeah. So now, first of all, looking at this, right? Looking from this diagram, you can see that the sliding plate is supposed to be beneath the pocket cube. So you are going to attach this face to this face. And of course, like this thing takes time. There are things called mates. So if you want to form an assembly, there are things called mates, whereby you can mate things together, circular mates, planar mates. So for today's session, we'll be using, I think, the planar mate, planar and circular for now. But for now, I think we are using the planar mate, and that's here. It's called planar. So what it does is that when you select two faces, it attaches them together. So in case you have your two hands like this, right? If you click on your palm and then your palm, and you click on the planar mates, it will join them like this. So it just combines two things together. So now, since if you want to attach the sliding plate here to like the bottom of the pocket cube, we are going to click on planar mates, and then now you just have to select the faces. So you click on this face and then this face. You can see that the circle, some circle stuff will come here. You see now it has joined. Is it okay? So now you can move. So now it's movable, right? But you can see that the two faces are joined. So now the sliding plate has now become beneath the pocket cube. So that's what the planar mate is. And also another mate we'll be using today, I've got to mention, it's called the width mate. So if you look at this, right, even though the sliding plate is beneath it, right, it's not fixed because it can still move. It can move up and down. It can go up, or I mean, like it can only go sideways, but it can't go like perpendicular. It can't go up and down, right? It can only go sideways because you have applied a planar mate, right? So it can go sideways, but it can't deviate from it being attached to this. Oh, even with this one, we need to come. I think I made an error even. Let me delete the planar mates and do it again. So again, planar mates, and then this phase. And I want to attach this phase to this phase. So yeah, and click solve. Okay. So now we have it. It's there. Now if you want to center this plate to the pocket cube so that it doesn't move sideways. So it doesn't move sideways, right? So there's something called the width mate. It's right here. Width here. It's called width mate. So what you do is that you first click on both sides. So first we want to center this side of the sliding plate to this side of the I mean, like, you see these two sides of the sliding plate here and then here. You want to center it to this face of the pocket cube. So we first click on this face of the sliding face, and then this face. Now you click on with mate connected. So you did the first one, now you need to click on the second one, because now if you're coming to click on the pocket cube, this side and this side. Yes, and you say okay. Now, what this has done is that now this side has been centered to the pocket cube, right? On this portion, on this side of things, right? So now you can only move the sliding plate up and down, but you can't move it sideways. It doesn't go, right? Because sideways it moves to the pocket cube. It doesn't go by itself because this side of the sliding plates has been centered from this portion. So now to prevent the sliding plate from moving up and down as well, we have to do the same thing for this side to fully center all the sides. Where is it? Okay. Yes, so this face. So we'll go back to the width mates. Click on this face. Click on this face. And then change to width mate connectors and click on the pocket cube side. And then this side. Now you say okay, and now the sliding plate is fully defined, right? It will only move with the pocket cube. It wouldn't move anywhere else, right? Because now you have attached it generally to the bottom face and also sideways as well. So it's fully defined in all of the directions. So that's how you can use a planar and then width mates. Mostly these are the kind of mates you'll be using for most of your CAD design. Planar mates, width mates, and circular mates for screws and holes, things like that. Yeah, these things are coming from the sketch, like the A button. It has like a floating, so you can just delete these things. We don't really need this, so we don't care about these ones. You just click on it and click on the delete button on your keyboard. It's coming from the SheSat Ghana text. Yeah. Yeah. Yep. So now that we have attached the sliding plates, now we are going to attach the cover. So with the cover, we are going to make this face flat with this face, right? Because it's supposed to be flush on the pocket cube because the height is 50. We can't go above 50, so we are going to make it flush. And also to remember to deselect something in Onshape, just go anywhere on a free space. Like for instance, if I click this, you need to double click on the white space here to deselect anything you want to deselect. So now we'll come back to planar mate, click on this top face, and then click on this face. You say okay. So what it has done is that it has made a cover flush. It has made this face we see here planar with this face. So it just makes it flush and sit inside, right? So now you have your cover. But of course now it's floating, right? It's floating. So I think what I did was I came back to the cover here in a part, right? And then I created like an extrusion here for just like mounting holes. So I'll just show you how. So you can, so basically it depends on you. Currently it's floating, right? So you as the structural or mechanical engineer, you have to watch and look at how you can fix this plate. Because remember that this is in a software, but if you actually make this part, it wouldn't be floating there. It will fall down on the ground. So you have to find a way to modify it to actually put some screws or something. So what I usually this model was I made a sketch on this face. I drew like some boxes here on the corner for mounting holes, and on this side as well. And then I just dimensioned it to how I want it. Like I made here 5 millimeters to the end. I made here 5 millimeters to the end, and I made the thickness of this too, because I didn't want it to be too big. I didn't need it to be too big, right? And then I same thing for this face. After this, we'll be done with the session, and then you can try it by yourself during your free time. So you can always pause the video and try it. And then I made the height too. Yep, and then I just extruded. I made it about 10 millimeters. Okay. So now, whatever you do here will reflect in the model. So it's because I did it on this face, it has. So I was supposed to do it on the back face, but it doesn't matter. We can just remove the planar mate here and then move it away, and then just turn it. So we can instead now make this face. So first of all, you click on planar, click on this face, and then this face. So now it has made it that way, but we want to flip it, right? So there's an arrow here called flip primary axis. You click on it and it just rotates your cover, right? And then now it's the opposite way. Now listen, here again to see it's flush, right? But we need to use the width mate again as well, because you need to center it in the middle of the space of this box. So now we need to center it both X and Y. So let's start with the width mate. So you come to width mate. So you select the side first, or like any of the sides you want. Remember, change to width mate connectors, and I'll click on this face and click on this face. So now you can see that it has shifted from the side to here. So now it has centered sideways. So now let's do the same for this side of things. So width mate, then you click this face, click this face, change to width mate connectors, then click on this face, then click on this face. I'm sure it's selected. I think it's loading or something. So I click on this face, and then this face. Yeah. When you say okay, I think there's something wrong. What is happening? Let me redo it again. Sometimes when you always get errors, so you just have to maybe just delete and do it again, or check, or things like that. Width mates. And Onshape is quite easy to learn how to use, because even I mostly use SolidWorks, but it took me like a day to learn how to use it. So you just watch enough tutorials. I even sent. I think I added like a link to the mess, so like the email we sent to a tutorial. You can always use that one. So you see now I clicked on both sides. Now it has centered in the middle. So now it's fully defined, right? When you right click on anything, right, on the box or something, there's something called make transparent right here. You can make it transparent and see what is inside. So you can always see what is inside your component and stuff like that. So essentially why I made these extrusions here was because I would make a hole on the cube also, like a hole. And then essentially when I 3D print it, I'll put like a screw there and just screw stuff to fix the top plates. But also remember all these things depends on what is inside your pocket cube. You can have PCBs or a camera here. So you need to know how much this would weigh, or maybe you need to change your way of mounting to ensure that nothing is interfering with what is. But because it's like a trial demo and there's nothing inside, I just assured it to 10. But mostly this depends on what you're putting inside to ensure that like nothing interferes with anything. So I'll come to the components box now. Let me see, where is the cover, the line for it, make transparent. So it's on the SheSat Ghana. Okay. So I'll come to SheSat Ghana and I'll make two holes. Two sketch. So again, you can click on circle to make the hole. There are different types of screws, so you have to research on like the size of screws. I'm using a screw called the M2 screw, and the diameter is I know is 2.4 millimeters. So I'm essentially going to create two holes here, and then I'm going to dimension them as 2.4. 2.4, and then I'm going to dimension the height from the position of them, right? Usually it's good to it's good to so it's good to dimension holes from the center point and not from like the edge of the hole. So you can come here again to measure details, the same place at where you train the millimeter stuff, and you can think I've forgotten how to do this. There's a way you can change the types of like the way you would measure. You can change it to, I thought it would show here anyway, but it doesn't seem to show. Like I'm also new to Onshape, but I mean I did this before. I'm just trying to remember how I got to that point. Because I wanted to change the dimension of this in such a way that you would measure from the center of the circle, not from the edge. But anyway, this still works, so I can see maybe I can make it like 5 millimeters, or let me say 7. Like give me a step. I'll make I'll do it again. I'll measure from here to here, make it. Oh wait, I think I saw something. Let me delete this. You're almost done, so don't worry. Just so when I measure this, right, like when you click on the dimension to and you are still on this face, right, you can see minimum distance right here. I think you can click on a yes, and then you can change it, right? So maximum distance will give you the ones on the part, but we want center distance, so we want it on center distance. So center distance is 7. So that's how you can change this stuff. But anyway, it's a little bit advanced. But for now, we can just use that. So 7, and then I want it also to be like maybe 10 millimeters apart. To not be solved. I think for now you can also click on it and I was just trying to dimension the two of them. Which can be created between these two items. Okay. But anyway, yeah, you can just add, so you can add like two holes, right? Two holes on each side, and then you can cut a hole through them. So you can remove and just make it long enough so that it appears on both sides and click OK. So you have your two holes. You have your two holes. So now you have your two holes on this side of things, right? So now you can what you can do is now you now have to create a hole on the cover plate as well, and then you can have a screw that goes through each side of it. Yeah. Is everyone still alive? 'Cause I feel like now it's getting
Oh yeah,
boring.
we are here. We are here. We are here. We are here.
Yeah. Yeah.
One person has raised their hand.
Yeah. You have any question? So we are basically done. So if you have any
Yeah.
questions, let me know.
Thibault, sorry if I didn't pronounce your name well. You can ask either in a chat or mute yourself. Okay, maybe. Okay, I think it was a mistake. Okay, all right, guys. Thank you guys so much. Thank you so much for coming for this program. And we ended with a hands-on session. We will be fine. We'll be fine. There are so many cover. We will be fine. So before we leave, very quickly, in just 5 minutes, could we just fill? I'm having to put a form in the chat. So just 5 minutes. So we can use this time to ask questions. I hope it's this one. We can use this time to ask questions. Yeah, I've put a form in the chat, so just fill that one out for me. Thank you. If there are any issues, let me know. Yeah, so if you can use this time to ask just 5 minutes, just 5 minutes. We can use this time to ask questions.
I'm getting my LinkedIn. Yeah, Jake.
Yes. Yeah, Jake.
Yeah. Yeah. Let's include a resource from YouTube for the Onshape thing, so that
Yes.
Okay.
Yes.
I think we can. I'll send it to like Mama, and then she'll add it to like the email she'll send with the
Okay.
recording.
The recordings. All right.
Or how do you send the participant the recordings? Is it through?
Oh, if
the
you
emails?
email, I'll just email everyone.
Yeah, and you can add the like it's like a package, like so you can add the link to the Onshape.
Okay, somebody is asking for the WhatsApp. Here is the WhatsApp. I'm put the WhatsApp inside. I hope it's this one.
So I'm attaching my LinkedIn right here.
Yes.
So you can just connect to me now, and then we can always have a talk here. Yeah. So this is the public queue. Yeah, and that's it.
Sorry, go on.
I was just saying that. So this is the public and stuff. We are done with the session for today because the time we've run out. So I just made two hosts here, but essentially, like when you reach the stage, you have to make two hosts again, like on the cover. I think the only challenging thing is that you have to make sure that you align the two holes you make on each side of these walls to align with what is here. Well, essentially, when you make or you 3D print it, you can just add like a screw or like a stick and tie it inside, and then the camera will stay still. So yeah, that's it for now. Yeah.
Great. I've also put the SheSat Ghana participants group link inside the chat. Yeah, do well to join that one as well. Thank you so much for joining this session. We have only 2 more sessions left. The next session will be the electronic session. That will be coming on about next month. And then the final session, that will actually be like a CANSAT modeling and CANSAT making. And so we will get you more information as time goes on. join our social media, our WhatsApp channels, the Xavier Space Solutions, and then the SheSat group, and we get all the information for you. When you fill out this the Google form that I just posted, you will get your your certificate sent to you via your email that you have indicated. Please do well to spell your name well so that we can get your actual name on there without any problems. So I think 5 minutes is up. I know it's been quite a long one, but thank you guys for sticking around. And for for your friends who aren't able to stay till the end, tell them to just DM me and I can check the participant list which I have and give them the form for them to fill for the certificate. Any final words, Jake, Daniel,
Someone is asking
Solomon?
for the Google Forms, but also wait, before we do that one, I just
Google Forms
proposed something. The sliding plates you see here also is not mechanically mounted, like it's just floating beneath it. So also when you are making it, you need to make some holes beneath it. Like you just need to think of a way to mechanically mount this to this by making like a hole here, maybe like a hole also on the cube to attach it here. So just remember. Yeah, that's it. Yeah. Yeah, that's it for me. Thanks.
Okay, yeah, thank you. So we have 7 people who have filled the form. So as and when, if anybody has any issues, just DM me and let me know. The Google form is in the chat. So just, yeah, it's in the chat. So just get the link from the chat. Yes, let me give it some 2 minutes. Jake, do you have any final words? Or Solomon, any final words?
Nothing really. Thank you all for joining today's session. You really never know how to do these things from just one session, and you need to practice and practice and practice. It just reminds me of when I was starting with AutoCAD some time back. You just need to practice and explore the different tools and shapes. There are actually different ways of actually designing this. I think Daniel started with drawing the shape itself and then removing some parts. You can actually design the wire stuff and then extrude that outwards. So you can just explore the different ways of designing this, and then you should get better. And then you can actually use this to design various stuff. Anything 3D you want to design, you can use this to design. So you can just explore all those other avenues. And like I said, thank you for joining. And then I think that's all from me.
Yeah, okay,
Thanks.
thank you.
Thanks.
Yeah,
Yeah,
thank you very much.
and Jake is right. Yeah, just it takes
Mhm.
a lot of time to learn how to, because even this stuff took I think like 6 months for me to even like get the hang of it. So but yeah, you have to be committed, and you have to do it every day, small every day like that before you can be used to this stuff. And Onshape is a really cool tool. I've seen engineers use it because and it's free, right? You don't have to pay for it. And
Yeah.
also take know that Onshape is like Google Docs. You can work with multiple people on one same project by just using the share button here, and you can type your friend's like mail address or something, like his email address or something, and then you can work on Google Docs and then be editing the same documents and stuff like that. So yeah.
Yeah, good. So we have reached the end of this session. Yes, thank you guys so much for coming. And just to add a little bit to what the people, our wonderful people have said, these things are just tools. They're just tools to help us design stuff. If you actually understand the design, as Daniel said earlier, if you're a mechanical engineer or a body engineer, if you understand exactly what you are doing, these tools will just be secondary to your work because you are actually working on something and helping you bring out what you're supposed to do. Yeah. So that's it. I'll be ending the meeting right now. Thank you guys so much for coming. Have a good day. I think, yes, Jerry, live long and prosper. Yes. Okay, then. So bye bye, everyone. Take care. Have a good rest of the afternoon and feel free to reach out. Daniel has put his LinkedIn in the chat. So You can. Thank you,
Sure,
Priscilla.
yeah.
Okay, so everybody, bye. Have a good day.
Bye.
Bye, 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 bye. Stop.